Hello everyone. In this lecture, I want to introduce the linear regression analysis by using Python and Jupyter to everyone. The linear regression analysis is one of the most frequently used models in business analytics. It can help us to investigate how one factor influences the other. I want to use an example to show everyone how to perform such analysis in Jupyter system. Let's see the example. Joe is a mobile app developer. He has a fitness app that offers the health information to users. Joe wants to bring his business to the next level. He wants to know more about the user population. Here we meet a new concept, population. I will talk about this concept in greater detail later in this lecture. Joe's question is, how would a user's yearly incomes influence the user's weekly length of usage of the mobile app? Joe has more than 2 million users. It's impossible for him to survey the entire population. So what he did was he drew a sample of 100 users and asked them how much they make every year and how long they would use the mobile app every week. We meet another new concept, sample. We'll talk about it later in this lecture. We want to build a linear regression model to analyze how a user's yearly incomes can influence how long she would use the mobile app every week. Before I talk about the linear regression model, I want to introduce some terminologies to everyone. First, population. A population is a group of research interests. Corresponding to population, we have another concept called a sample. A sample is a part of a population. In our example, Joe's 2 million mobile app users is the population. That is the group we are interested in. Because we are unable to survey every one of the users in the 2 million population, we only look at 100 users. These 100 users formed a sample. It provides an opportunity for us to look at the sample, and then we want to infer the findings from the sample to the population. It's very important to differentiate these two concepts. Keep in mind that we are interested in the relationship between yearly incomes and how long the mobile app user will use the app of the population. We just use the sample as an example to look at the relationship, and then we want to find a way to infer the findings from the sample to the population. We'll further talk about this relationship later in this lecture. We have another two important concepts, dependent variable and independent variable. A dependent variable is a factor being influenced by others. An independent variable is a factor that influences others. In our case, we want to look at how the user's yearly incomes influence how long she would use the mobile app. Then how long she would use the mobile app is a dependent variable. The user's yearly incomes is then the independent variable. Keep in mind about these two concepts. Next, I want to show everyone how to perform the linear regression analysis in the Jupyter system. This is the web address, try.jupyter.org. This is the cloud computing platform. Do you still remember how we can upload the data set, the source data set, to the Jupyter system? Yes, we need to go to Datasets. Click on Datasets. And then we need to go to another datasets folder. And then click Upload. And then find the source data file, fitnessapp.csv file, and then click Upload. make sure the source data file is listed in the list. And then we can go back to the home page. Let's go to Welcome to Python. And then click the plus sign to create a cell. Next, we want to type in import pandas as PD. This is the library we want to use when we perform business analytics when we use Python, pandas library. And then we want to create a variable called df. df equals to pd.read_csv parentheses. We need to specify two parameters. First, the directory and the name of the source file. Let's type in datasets/datasets, and then fitness app.csv, and then a comma, and then type in SEP equals to two double quotes, and then another comma. If we want to see the source data, we can type in df, and then press Shift key and the Enter key on the keyboard at the same time. This is the data frame we just imported to the Jupyter system. As you can see, in this data frame, we ask each user how much she makes every year, how many times she visits gyms every week, where she's come from, and how long she will use the mobile app. We have hours, we have incomes. We want to use incomes to predict how long the user would use the mobile app every week. In the previous lecture, we talked about data visualization. It would be better if we can take a look at the relationship between incomes and hours in a graph, right? Let's create such a graph. Before we perform data visualization, we have to import another library. It is matplot library, right? Let's type in import matplotlib as plt. We created a variable called plt and then import all the data visualization function from matplot library to the variable plt. And then after df, we want to type in .plot. This time we need to specify three parameters inside of the parentheses. First, what type of a graph we want to draw. Type in kind equals to double quotes. We want to type in scatter. We want to draw a scatter plot chart. Comma, x equals to incomes. X indicates the values that should be listed on the x-axis. In business analytics, we usually list the independent variable values on the x-axis. In our case, incomes is the independent variable. So we want to list the values for incomes on the x-axis. And then another comma, y equals to two double quotes, hours. Needless to say, on the y-axis, we want to show the dependent variables values. In our case, hours is the dependent variable. So we want to indicate the values in the hours column should be listed on the y-axis. Let's see the result. Let's press Enter and Shift key at the same time. This is the chart showing the relationship between incomes and hours. As you can see, there is some relationship between the two factors, right? The more incomes a user has, the more hours she would use the mobile app every week. We have got the overview about the relationship between incomes and hours. But it would be better if we can build a more accurate equation to show how exactly the user's incomes influence how long she will use the mobile app, right? let's build this equation. When we want to build the equation, we have to import another library. It's called the stats model library. It's a bit long, so you can copy it from the PowerPoint. It is listed in slide number 5. Import statsmodel.formula.api. You can copy this statement and then paste it into Jupyter. We do the same. We create an alias or a variable to represent this library. The variable we created here is called the SMAPI. We use the import statement to bring all the functions from the stat model library to this variable SMAPI we just created. Now let's build the model. First, let's remove the statement that can create the chart. And then we want to create a new variable called LM. LM equals to SMAPI. This is the variable that represents the stat model library. .OLS. OLS represents ordinary least squares value. This is an approach of performing the linear regression analysis in Python. Parentheses. We have to specify two parameters between the parentheses. First, formula equals to two double quotes. Here you want to indicate which one is the dependent variable, which one is the independent variable. In our case, we want to use hours as the dependent variable. And then a tilde sign, a symbol like this. The tilde sign is in the upper left corner on your keyboard. If you are using a Windows PC, it should be below the ESC key. It's called a tilde sign. After tilde sign, we want to type in the independent variable. In our case, it's incomes. This is how you tell the Python system what kind of model, which is the independent variable, which one is the dependent variable in the linear regression model. And then a comma. The second parameter is data, where the source data frame is stored. At this moment, we stored the source data frame into the variable df. So after the equal sign, let's type in df. Let's jump out of the parentheses and then type in a dot. Next, we want to type in fit and then parentheses. This is how you build the linear regression model in the Jupyter system. We're ready to see the result. If you want to see the result, let's type in lm.summary parentheses. And then you can click Enter key and Shift key on your keyboard together to see the result. This is the linear analysis result from a Python system. Let's talk about this result one by one. When you get the analysis result, the first factor you want to look at is the COEF factor. COEF represents coefficients. It shows how the independent variable influences the dependent variable. From our current analysis result, the coefficient for intercept is 1.464. I round the number to 3 digits after the decimal points. So we can say the coefficient for intercept is 1.464. The coefficient for incomes is 0.066. According to these two values, we can build the relationship like the one listed at the bottom of this slide. Hours equals to 1.464 plus 0.066 times incomes factors. How can we use this equation? After we build this equation, we can understand the relationship, how the incomes factor influences the hours factor. In the future, if we know the user's yearly incomes, we can use this equation to predict how long she will use the mobile app. Let's say we know a user's yearly income is about $100,000. We can put 100 into the equation, and then we can get 8.06 hours. That means if a user's yearly income is about $100,000 a year, based on our analysis result, we predict that the user would use the mobile app for about 8.06 hours every week. This is how you use the equation to predict how long the user will use the mobile app. What if a user can get $50,000 a year? You just put 50 into the equation, and then you can predict how long she will use the mobile app. Remember, when you get the analysis result, COEF values are the first values you want to look at. It shows how the independent variable influences the dependent variable. Next, we want to figure out a relationship. At the beginning of this lecture, I talked about the difference between population and sample. I said population is a group we are really interested in. We actually want to figure out how the user's incomes influence how long the user uses the mobile app among the population. But because population is so difficult, so costly to survey, to study, we really cannot look at the population. That's why we draw a sample from this population. Currently, we build the relationship between hours and incomes. From this sample, from the current sample, I see hours equals to 1.464 plus 0.066 times incomes. From this sample, I found how the user's incomes influences how long she will use the mobile app. But the question is, does this equation still hold in the entire population? How can you convince the data user? You build a model from 100 samples, and you can infer the model into the population. This is a very good question, right? In order to achieve this goal, we want to compare p-values to the level of significance. In practice, the level of significance is usually set at 0.05 or 0.01. These are the standards for us to infer the relationship from the sample to the population. It's up to the business analyst to choose which value to use. You can choose either 0.05 or 0.01. In medical research, you want to choose a smaller number, so you want to make the standard even more stricter. In business analytics, 0.05 is an acceptable level of significance. After you identify the level of significance value, the next value you want to look at is called a p-value. P-value is the value you get from the data analysis result. If p-value for an independent variable is less than the level of significance value, we call this independent variable a significant influential factor of the dependent variable. In other words, if an independent variable is significant, its coefficient can be inferred to the population. Let's use these rules to evaluate our data analysis results. How can we get the p-value? It's listed in this column. P greater than absolute value of t. We want to look at this column. Let's look at the p-value for incomes. It is 0.000. It's so small that the Python system cannot even show the exact number. Obviously, this p-value is much smaller than 0.05 or even 0.01. According to the data analysis result, we can see that incomes is a significant influential factor of the dependent variable hours. Also, according to the rule we just learned, we can predict that the relationship between hours and incomes still holds in the population. That means we build this equation based on 100 samples, but if we bring this relationship to the population of 2 million, 3 million, or even more users, the equation still holds. You can draw any one of the user among the 2 million population, ask the user's yearly incomes, plug in the number. We can use this equation to predict how long she would use the mobile app. This is the second factor you want to look at. Some classmates may have a question. What if I choose 0.05 as the level of significance value? After my analysis, I found out the p-value for incomes is greater than 0.05. What conclusions can I make? According to the rules we just learned, if p-value of incomes is greater than 0.05, we cannot say incomes is a significant influential factor of hours. What does this mean? That means we can build such an equation based on 100 samples. However, this equation is only applied to these 100 samples. We cannot infer the population has the same equation. What should we do if p-value of incomes is greater than the level of significance? What we can do is to draw another sample and then build another equation to see in that equation if the p-value of incomes is less than the level of significance value. The last factor we want to look at is called the R-squared value. The formal name of R-squared value is called the coefficient of determination. The reason we call it R-squared value is that most software will report the value as R-squared value, as you can see on this slide. In most of the software, you can get two R-squared value, either R-squared or adjusted R-squared. You can use either one of these two values. They are very similar, not a big difference. But we do want to figure out what R-squared value represents. It represents the percentage of the dependent variable's change that can be predicted by the independent variable. In our case, let's use the R-squared value. It's 0.649. It's about 65%. What does this mean? This means if the user's mobile app usage changes by 1 hour, about 65% of this 1 hour change can be predicted by the user's incomes factor. Some classmates may have a question. Now I predicted about 65% of this 1 hour change. What about the other 35% change? What we can do is to keep adding more independent variables into the equation. Let me show you. Let's go back to Jupyter. This is the model we just built, right? We use incomes to predict how long the user will use the mobile app. Now, besides incomes, I want to add the second independent variable. I want to type in a plus sign and then type in gym visits. I want to use incomes and gym visit to predict how long the user will use the mobile app at the same time. Let's press Enter and Shift key to see the results. Now you can see R-squared value is increased, right? Increased to about 80%. That means if we use two independent variables to predict hours at the same time, if the user changes the usage by 1 hour, about 80% of this 1 hour change can be predicted by incomes and gym visits together. Also, let's take a look at this new analysis results. The first factor you want to look at is COEF. It shows how the independent variables influence the dependent variable. According to our new analysis results, we can see that hours equals to 0.3282 plus 0.062 times incomes plus 0.5001 times gym visits. According to this equation, you can ask two questions to the users in the future. How much you make every year? How many times you go to gym every week? Plug in these two numbers, you can predict how long the user will use the mobile app. The second factor you want to look at is the p-value. Both of the p-value are very small, so we can see that the equation we build according to these 100 samples can be applied to the population. This equation still holds in the population. The third factor we want to look at is the R-squared value. Obviously, R-squared value is increased now because we consider the user's mobile app usage from more than one perspective. We also take the user's gym visits factor into account. That's why the R-squared value is increased to about 80%. A rule of thumb is the more independent variables you add into the equation, the larger the R-squared value will be. This is how you perform the linear regression analysis in the Jupyter and the Python system.